Security for the popular chat application Slack is a major focus for the company. A corporate Slack account is as valuable to a hacker as a corporate email account. In today's episode, Ryan Huber and I talk through Slack's approach to security, from philosophical discussions of how the company approaches security to the technical practices of logging and monitoring, and why Slack has a separate Amazon Web Services account just for the security team. Ryan works on security at Slack, and he has written a Medium post called Distributed Security Alerting. I recommend checking that article out if you have not already. And if you haven't heard the episode that I recently did about Slack's architecture with Keith Adams, definitely check out that episode. It was really, really fascinating. And this is a great follow-up. I hope to do more shows about Slack because it's obviously an interesting company with interesting technical challenges. So I hope you enjoy this episode. Continuous integration is so useful that I've started using it on my own personal projects. SnapCI from Thoughtworks has the fastest setup I've ever seen. I registered for SnapCI with my GitHub account, and after a few clicks, I had continuous integration pipelines set up for a Node.js application and a Rails application that were just sitting on my GitHub account. And I don't want my users to experience breaking changes, so I want to run a large suite of tests for my application every time I push a change. And SnapCI will run those tests quickly, in parallel, on a worker that SnapCI spins up and takes care of for me. Whether you have personal projects like me, or you work at a company that is looking for the perfect tool to improve the deployment process, go to snap.ci/softwareengineeringdaily. SnapCI embodies the lessons that Thoughtworks has learned from 20 years of software deployment, the same lessons that have been written about by Martin Fowler and Jez Humble. Check it out at snap.ci/softwareengineeringdaily. It would support Software Engineering Daily, and you would get to check out continuous deployment. snap.ci/softwareengineeringdaily. Thanks for listening. Ryan Huber works on security at Slack. Ryan, welcome to Software Engineering Daily.
Thank you.
So what are the high-level challenges around securing a chat client like Slack?
At a high level, when you think about risk, I mean, what we're actually protecting here is communication data, right? So the threat model for a company like Slack is similar to something like, say, Gmail or any communication provider. And so the challenges are, ensuring that only the people we expect to have access to data have access to that data.
Okay, so describe the surface area of attack. Oh, by the way, it is recording.
Okay.
Yeah.
Sorry. Cool.
Yeah. So describe the surface area of attacks that you think about for Slack.
So there are a number of attacks that I think about. I do a lot of defensive security. So the number one attack vector I tend to think about is credential theft, just because it's extremely simple and extremely common. A lot of the reports that come out every year cite credential theft as by and large the number one thing that leads to a breach. So, when thinking about how to secure things, we think about how to secure employee accounts using things like two-factor authentication, but also how we can protect our users and offer things like two-factor authentication to them.
And how effective are those tools? I mean, we've had two-factor authentication for a while. Is that an effective tool for preventing attacks based on credential theft?
Yeah, it definitely is. As long as you're doing the right thing with your second factor. So there are multiple types of two-factor. There's the newer one, which is U2F, Universal Two-Factor, which is extremely good. Then we have TOTP, which is the time-based codes everyone knows about, where you have a 6-digit number, which is also quite good. And then there's SMS, which in my opinion, is less good than the others these days. So for the most part, two-factor is going to thwart most attempts as long as they don't have some other way to get into the system that they're attacking. And the reason I cite SMS as a problem is just that we've seen a lot of cases over the past few years where telecom providers just don't secure access to the SMS messages themselves sometimes, and that can lead to a compromise as well. So I very much favor things like push two-factor, U2F, and TOTP.
Got it. Yeah, we did a couple episodes recently that are kind of relevant to this. We had Troy Hunt, who is the guy that runs haveibeenponed.com, which is like this site where you can see if your credentials have been stolen in one of these giant data breaches. And then we also did a show about pin drop security, where the discussion was basically about securing call centers and just how many holes there are in how many potential man-in-the-middle opportunities there are. Even for something like, if you're making a VoIP call to somebody or sending a text message to somebody, you might think of these things as fairly secure mediums of communication, but there are opportunities for man-in-the-middle attacks.
Absolutely. And funny that you mention it, I just got an email from Have I Been Poned this morning. I don't know if you know about the recent issue. Yes, exactly. So I just got an email from Troy this morning.
Yes. Did you change your password? I changed mine.
I did. I actually changed it last week when they announced. But it was an interesting case of they wanted everyone to change it regardless of how good your password was.
Yeah, which is probably that's a pretty good standard to have. So coming back to Slack. Yeah, so coming back to Slack, you wrote a blog post a while ago about security at Slack, and it was called Distributed Security Alerting. I'd like to talk through some of the details of this post. And you started off the blog with the question, how does a company know it has been hacked? So what are the typical answers to this question? How does a company know if it has been hacked?
Well, so right in the blog post, I guess the ways I thought of were some employee notices something strange. So that could be someone on the security team perhaps, but also could just be, any individual employee noticing something strange, some strange access to their accounts, anything like that. And as I mentioned in the post, that's kind of the best case, right? That means at least it's contained to your company, and you might have a chance to sort of form the messaging around whatever's happened, and maybe it's not even that severe because it's been caught right away. So maybe something like Google has notified your employee that one of their accounts was compromised, and they should take a look at it, right? The next way is something like a third-party notification. So that's when for instance, an external security company, perhaps the government, the FBI, someone else notifies you that they've seen something that indicates a breach. And that could be a number of things. That could be chatter on, underground trading forums where they trade credentials, all the way to, somebody has dumped something on a command and control server, if you're familiar with the term, that maybe points back to you. So that's less good because it means that your breach has potentially been happening for a while. And then I think the worst case in all of this, there's another one on the blog post, but I think the worst case is not noticing a breach at all and any sort of ongoing breach. And I think these are, I don't want to say common. I don't have any quantitative data here, but I think that they are relatively common, especially in smaller companies.
Okay, so if a company knows it has been hacked, what are the typical ways that it can respond?
If you have a security team, right away you're going to spin up an incident. If you have an incident response team, you'll start handling it. You'll start looking at your run books, and you'll go after, locking down access, but also preserving evidence. And that's one step that is sometimes missed and is extremely important, because if you don't preserve evidence or whatever logs you have, it's going to be very difficult to prevent the same type of breach again, right? If you're not exactly sure how it happened, then there's a chance you didn't catch the source of the breach. If you don't have a dedicated incident response team, there are a number of firms that you can contract to come in and help you, and there are people you can reach out to that will come in and help sort of do crisis management with something like that. But the advice I've had from other people is a breach is more of a marathon than a race, and I think one of the worst things that you can do is actually disclose the information about your breach before you have the complete story and before you've really verified that story. Because if you come out and then have to amend what you said in your disclosure, that makes it appear that, perhaps you don't quite know what you're doing security-wise, something to that effect.
Yeah. And so you mentioned this might be more epidemic among, there might be certain more severe cases that are more epidemic among smaller companies. Maybe that's because the smaller companies don't have as much of a security infrastructure. They may not have processes in place. They may not have employees in place whose job it is to work on security, or maybe even sysadmin stuff. What are some strategies that a smaller company can employ to ensure that they have some degree of security, or should they bring in somebody from outside every now and then to audit their system, or what are the strategies they should employ?
There are a few things they can do. I think at a base level, having a bug bounty program is a good start. Bug bounties, vary in quality, and you can get different levels of researcher giving you different levels of bugs, and it is financially motivated in a lot of cases, but it is a really good way to at least get some of the low-hanging fruit. And one of the things a bug bounty can also do for your company is act as sort of a wake-up call that, we think we're mostly fine, and then we open up a bug bounty program and realize, oh no, we're not fine. We actually need to do some work here. So it can actually function to, not only help you close some vulnerabilities, but also put things in perspective. And as far as other things a company can do, I think just having good operational practices is a really great step. So DevOps, whatever you want to call it these days, I think DevOps is still okay to say. That's having those sort of practices where you have repeatable processes, automated processes that allow you to stand up infrastructure. That's a really good thing because it means that your infrastructure won't be a number of one-off servers or things like that maybe aren't maintained. It's not going to lead to some security panacea, but it's still going to put you in a much better position than if you've willy-nilly set up your infrastructure.
Interesting. Okay, so talking more about your blog post, I got the sense that you focus as much on identifying when a hack has actually occurred as you do focus on trying to create an impenetrable fortress that can't be hacked. And this is a subtle point because securing a system is actually a much different problem than identifying a system breach after it has occurred. Would you say it's an accurate distinction?
Absolutely. I think there's no such thing as absolute security. We're reminded of that every time a new vulnerability comes out. And so I think you have to attack the problem from the other side and say, I'm going to detect something as quickly as possible. I think that's more important than trying to be perfectly secure.
Okay. And you write that a great security team should probably be building things instead of staring at logs. So what are the kinds of things that a security team can build?
One example of something we've built here is it's about to be open sourced. It'll be open sourced the third quarter of this year, which we're in right now, so very soon. Something called Go Audit. And this actually plugs into the Linux AuditD framework. It's written in Go, and it takes the AuditD logs, which are a bit difficult to parse, and turns them into JSON, which you can then stream to sort of a central repository. And so one of the first things we built as a security operations team is a reliable logging pipeline where we're taking all of the data, all of the process execution data, socket data, file access data, lots of stuff out of all of our production servers, no exceptions, and we're shipping it across and storing it off host. So we're storing it in Elasticsearch in a way that we can go and look at. And we look at that both manually and with automated processes. And that's really one of the key points here. We're not doing on-host detection of interesting or strange activity. We're doing it off host. So we're shipping all of this data, everything happening on a system, off host as quickly as possible.
Right. So the logging data seems like basically the source of truth for a security team. So maybe you could tell me to what degree that's true and how you have set up logging infrastructure aside from just creating a service that converts the logs into JSON data and streams it. What are the other aspects of infrastructure you've built up around logging?
So our security operations team actually has their own AWS account, and that's separate from all of the production systems. So that AWS account only has 4 or 5 people that can actually log in to any of the servers, that can look at the AWS console, any of that stuff. And what that gives us right away is we're not dependent on production security to ensure that some level of certainty that our logs are intact, even if there is an incident. And so what we've done is we actually connect that AWS account to prod via sort of a logging pipeline. And the nuts and bolts of that are we use our syslog on our production hosts and a protocol called RELP, which is a reliable logging protocol. So normally when you send syslog off host, it's UDP. In its basic form, it's UDP. If it's dropped, no big deal. In our case, we use RELP, which ensures delivery to some extent until you fill up the disk or something like that. But for the most part, you can be pretty sure those logs are going to make it across. And our syslog on each host in production connects across to something called StreamStash, which is very similar to Logstash, if you're familiar with that. And that's actually running on the SecOps side. So no part of the logging infrastructure lives on the production side other than our syslog running on each host. And on the security operations side, that StreamStash cluster actually takes all of those RELP connections, does what it needs to do with the data, and then drops that into Elasticsearch.
Got it. And talk more about the reasoning behind this security operations cluster on AWS, or I'm sorry, the entire separate AWS account for SecOps. Why does that make sense?
The main reason is because, we have how many engineers now? I think we have a couple of hundred engineers. And while most of them don't have access to production, we only have a few people doing security operations. We have a team of 4 people. The security team itself is 12 people, but security operations is a subset of that, and it's only 4 people right now. And those 4 people, we can be reasonably sure that those people have extremely good security hygiene, right? So it's not to say that anyone is bad at security necessarily, but we have this case where we know this set of people is very good at security. So why don't we set up an environment that only they have access to, and then we don't have to worry about as many things, right? So we still keep it updated, keep it patched, whatever, but we don't have to worry about there being a lot of vectors of attack, including having 100 different accounts that could lead to a compromise of that system versus just a few.
So this is principle of least privilege applied to your own cloud, basically.
Absolutely. And the only thing shared between production and SecOps is billing, which is fantastic.
It makes sense. So, and one application of the cloud that you mentioned that was pretty cool is, if you need to look at all of your historical log data, in an ad hoc fashion, you can just spin up a bunch of instances all at once to look at all of this data. What is the case where you've had to do this, or why would you want to do this?
So we keep a lot of data online. I'll give you some rough numbers, but I think we have about 10 terabytes of data online in the SecOps cluster at any given moment. But that's every process execution from every box for the last, I want to say 2 months is what we keep online. So that's a good amount of time. But there's definitely a case where you're going to want to look back at historical logs, and it's not really worthwhile to keep those online because most of what we're doing is going to be in a much more recent time window. But having some capability to take those old archived logs out and put them online quickly so you can do an investigation is extremely handy. And in the cases where we've done it in SecOps, it's actually been related to validating that a behavior has been going on for a long time, right? Or going back and just sort of validating when something started. But it also applies to things like weblogs. So we've gone back and, if a customer perhaps needs help with something, security related, what we can do is actually go back and pull our weblogs in and put those into the cluster as well. And it's a massive amount of data. It's just, it wouldn't be feasible to keep that data online. The cost would be enormous. So it's really handy for that. And what's great is with something like a cloud environment, as long as we don't hit whatever our limit is on instances, we can basically spin up an unlimited number of hosts, and we can bring those online, and we can stream the data out to them very quickly. So, in a lot of cases, we can have something like our weblogs for, say, 6 months online in a matter of an hour, and that's really powerful.
Okay, so what kinds of things is the raw log data being turned into, on a regular basis, rather than on an ad hoc, you're troubleshooting some issue type of basis? Do you use the logs to generate some metrics or dashboards that maybe some DevOps people are looking at on a regular basis?
Absolutely, and there are actually two separate logging infrastructures. So as I mentioned, security operations runs our own. We have our own Elasticsearch cluster that does a lot of sort of low-level stuff, but then we actually use Elasticsearch in production as well, and that's something that like our entire operations team uses. So, we also, on top of that, we use StatsD, we use a couple of other things that to monitor sort of the DevOps side of things, but we definitely use the production Logstash cluster to look for problems and to go back and look at why maybe we had a drop off in connections, that kind of thing. So it's quite common to go look at that data, and I'd say at any given moment there are at least a couple of engineers at Slack probably using the production Logstash cluster to look into an issue.
Now, there are some logging tools that you can buy off the shelf, like Loggly or Sumo Logic. Why do you choose to roll your own rather than buying something off the shelf?
We looked at a couple of interesting ones. I think Graylog's another one that potentially we looked at. We looked at a few of these, and they seem great, but specifically for the case of SecOps, it didn't seem right to outsource that bit. So I'm very much a cloud first, use cloud services. I'm very happy to use cloud services in most cases, but in the case of sort of your most sensitive data, I much prefer to run that infrastructure ourselves, just to ensure that we've done the right things as far as securing that data, because there are potentially sensitive things in there as well. I mean, if you think about process spawning on a Linux box, how often in the command line is there something like a password, right? So I wouldn't feel very comfortable shipping that off, regardless of how good the security of that provider is. And to answer that in the context of Slack as a whole, I think that we have an extremely strong operations team, and they just went after the problem and said, we would like to run Elasticsearch ourselves because we can handle scaling it quickly, and most likely the cost is a bit lower as well.
Right. Now, so is that a statement that encompasses, like, you would say that's for all applications? This is just something like in the build versus buy spectrum, just always build your logging infrastructure? Or is this more a case of where, Slack has a service with some privacy concerns, with some informational concerns, with, it got a lot of private information, and also the team is large enough where you could build could build your own logging infrastructure. You've got the right people there. I mean, what are the cases where, when you think about the spectrum of companies, when somebody should buy their own buy the logging infrastructure rather than build it?
I think any company, like you mentioned, sort of smaller companies and what are they doing, and I think a lot of smaller companies don't even bother centralizing their logs. And I think it's a great starting point. I think at least logging somewhere is better than nothing in almost every case. So if you're not considering doing this yourself already, then absolutely consider using a third party to do it, because in reality most of them are probably going to be good custodians of your data. And so again, I emphasize that logging something is better than not paying attention to your logs at all.
Yeah. Okay. What about other build versus buy stuff? Is there any monitoring or dashboarding solutions that you buy?
I have to think about that for a second. So in the case of security, we actually buy very few tools, and that's not to say that we're very much a build versus buy shop. I actually much prefer when somebody else has sort of solved a problem. But the number of security vendors that we use is quite small. And as far as interesting bits, I'm going to trail off here. I don't even know. We've built most of the stuff ourselves. We're open sourcing most of it. And one interesting thing here is that I've spoken to security teams at a number of companies, and we're all solving these problems internally. We're not even all sharing some of the defensive information, some of the defensive techniques and tools, but we're all solving the same problems behind the scenes. And that to me tells me that there aren't the products out there in this space to solve the needs of sort of at least our class of company, a modern tech company.
Wealthfront is an automated investing service that saves you time. As an engineer, your time is valuable. If you want to invest, but you don't want to spend significant time evaluating your portfolio and allocating assets, take a look at Wealthfront. Go to wealthfront.com/SE Daily to open an account today and get a special offer for Software Engineering Daily listeners. $15,000 managed for free when you open your account. With traditional investment services, there are many humans in the loop that are doing things that Wealthfront automates away. When you pay the commissions and account fees of these traditional investment services, you're paying for work that could be done by a computer. So don't pay commissions and account fees. Maximize your gains with Wealthfront's Set It and Forget It investment automation. Check out wealthfront.com/SE Daily. It would support Software Engineering Daily, and it would introduce you to the world of automated investing. Wealthfront.com/SE Daily. Thanks to Wealthfront for being a continued sponsor of the show. Now let's get on with the show. So what are those canonical problems that are not easily, or that are not being solved by the products in the market?
I think one of the ones that really has my attention right now is endpoint inventory control. And in this context, endpoint to me means a user laptop or a user machine, not something in production. It can mean both. But there's a fantastic couple of papers. I don't know if you've seen them, but the Google BeyondCorp papers. I'm a big fan of the work Google has done here, and they have the resources to do some pretty amazing work. What they've done is actually they've as far as I know, they've removed all VPNs for access to backend systems at Google, and the reasoning is VPNs aren't really going to help you much when you have tens of thousands of employees, right? That's a number of people that you can't protect perfectly from things like malware. And so if you're depending on a VPN to keep people from doing bad things, that's going to be a bit more difficult. So the approach they took was to attest to whether a device was one they gave the person, whether it's patched, whether it's reporting in through all of their agents, all of the tools that they have installed on it. And so the BeyondCorp papers go into some detail on how they do that. The most difficult aspect from the most recent paper, the one that came out just this year, it seems like the most difficult piece of this was actually aggregating all of that data from different sources and then making a decision, right? So if you have antivirus installed and then you have have something like OS Query and all these other tools that have agents on the box. How do you actually correlate that data to make an informed decision about one machine that's being reported on through multiple channels? And so that inventory management piece is something that there are definitely inventory management systems out there, and there are endpoint control systems, but I haven't seen anything that really approaches what Google's doing in this space. And so I hope that there are vendors that come along and say, I think there's an opportunity here to aggregate this data across a fleet of end user machines, so that we can make decisions about whether that machine is secure or not. And to expand on that, what Google does with this data is then they decide whether a machine can access a backend resource rather dynamically. So they use this inventory system to say, okay, this, for instance, this box has not had antivirus running in a week, so I no longer trust it. And they cut off that actual machine from accessing a backend resource in an automated fashion, which I think is extremely cool.
Well, the Google papers are basically the leading indicator for what companies are going to be built in 5 years. So probably this will lead to some kind of company being built and some kind of product being offered. I did just put a note to contact somebody from these Beyond Corp papers. I haven't heard of them, but it sounds like this would make for a great show. So, I think one thing that we kind of glossed over is there's security operations, there's also DevOps, and both of these types of organizations or sectors within a company are trying to do something around monitoring. So maybe we could clarify this a little bit more. Like, what is the difference between how the DevOps organization thinks about monitoring and how the security operations team thinks about monitoring?
We have a lot of parallels between the teams, and as far as teams that work closely together but are under different parts of the organization, I'd say at Slack at least, security operations and operations work together on a daily basis. And the reason for that is we have a lot of operational experience. People on the security operations team have deep development and operational experience. So there's just a lot of crossover between the two, and I think that's the way it should be. I do like the separation there, where the priorities are slightly different, right? An operations team, historically, their job is keep everything running, right? Keep the plates spinning. Whereas the security operations team is trying to keep nefarious actors from doing nefarious things. And there are a lot of crossover points there, though. Like, we actually run some infrastructure in the critical path. So we run some of the infrastructure that helps protect secrets, but that infrastructure has to be online 24/7. And so our monitoring systems are very similar, and in some cases crossover between sides where we're on call for certain issues. And I don't know how common this is in companies right now. I think security operations team, whatever you want to call them, SecOps, DevSecOps, whatever we want to call it, I think is sort of a growing trend. And it's an area where historically security has been sort of the no-sayers in a company. I mean, in maybe less healthy organizations, they say no, or they're blockers, and they help out. But I think having some ownership of security issues and actually helping develop solutions is sort of the way forward in a lot of this. And so I look forward to more companies potentially having security operations teams where they're sort of proactively building solutions for problems that are out there and not leaning on other parts of the organization. I think that's something that allows you to have a more secure sort of organization without slowing down the operations team or without compromising sort of availability and all the things that they're concerned about.
Right. Well, and that security operations not being no-sayers or being less of a no-sayer, I think it's also true of DevOps, not being no-sayers compared to the previous incarnation of DevOps, which is probably sysadmin. And like we had James Turnbull on the show recently, and he talked about proactive monitoring rather than reactive monitoring. And I think this measure of proactivity ties into what you were saying earlier about like a security team should be building things instead of just staring at logs and like looking for some kind of anomaly and then responding to that anomaly. It's really more about proactively building things, just like developers would be thinking about it.
Yep, and a lot of the, when we were hiring for the security operations team, one of the things I really look for are people with sort of deep development and operational experience. I think it's the case that, and myself included, like a lot of people that come from a security background don't have the sort of the sort of good coding practices or the good they don't write great run books, whatever. And I think a lot of those things, when you pick up a dev or an ops person and bring them into a security organization, you can bring them up to speed on a lot of security stuff. And in reality, we all deal with security. Like devs and operators deal with security issues all the time now, and it's very much at the forefront of what they're thinking about. And so it's not hard to explain or bring them into the fold and have them understand issues related to security. Whereas I think taking a historical security person and maybe putting them into a role where they're doing collaborative development on a project is not something that's quite as easy.
Talking about incident response, you write that when something bad happens, assuming you have enabled logging, the first indication is probably sitting right there in a log. Could you give an example of using logs to deconstruct when something bad has happened? Like, I'd love to get your perspective on incident response.
Absolutely. So when actually I can speak to like an incident that unrelated to Slack, but that I thought was quite interesting. If I forget and say a name, just bleep it out.
Okay.
So one thing that was great was this company in particular did a lot of logging, and they had all of this data. But then there's a technique that I'd used in the past, which is do some disk forensics and actually put that into Elasticsearch as well. And so what was great about this was they had all of this data, like let's say SSH logs, general authentication logs of all types, and it was all already in an Elasticsearch cluster. So then what you could do is go do something called forensic disk timelining. I don't know if you're familiar with it, but you take sort of the access times of files, and you can put those into sequence and then put those in Elasticsearch. And what's great is now you have this one data source where you can go look and see, okay, this person, there was an SSH into this box, and then I can see what files were affected while that person was logged into the box, and then go back out. And that's a really great trail of data. If you're doing an investigation, I mean, that's a gold mine. So, having the authentication logs, having ideally AuditD logs, but just having all of that stuff in one place means that you can sort of massage that data and do different things with it than you might have even intended to do with it in the first place.
You've mentioned AuditD a couple times. What is AuditD? It's
my favorite thing. So AuditD is a subsystem in the Linux kernel that I'll probably get this wrong. I think it's been in the kernel since 2.4. And what AuditD lets you do is actually tell the kernel, I want to be notified for a certain type of syscall. And so you can tell AuditD, I want to monitor basically any syscall on a Linux machine. And a syscall is something like a process being spawned, a socket being opened, a file being read or written. And you can tie into any of these syscalls with AuditD, and then you connect a daemon to the kernel that actually reads that stream of data. So as an example, if I set up an AuditD rule that says anytime a socket listener is created, I'd like an event, I put that rule in that rule is actually in kernel memory, and every time that syscall fires over something called a netlink socket, which is a bit nuts and bolts, but over a netlink socket, a process, an AuditD user space process, will receive notification of that, and that's sort of the piece that Go Audit fulfills. So Go Audit will receive that message from the kernel, and it will package it up nicely in JSON and say, okay, here's an event, socket created, listener port 555, and send that on. And what's really powerful about that is you can also do it on files. So if you have sensitive files on a system, I mean, everyone uses TLS, right? So if you want to watch something like your certificates and see if anyone's read them or tried to read them, great for that. And I mean, it's really unlimited, but it is a lot of data. And so the thing that people often people will try out AuditD, they'll turn it on, and then they'll watch the load on their system go to 90. And the reason is you can't really just turn on AuditD in full logging for every syscall and hope for the best. You need to understand your environment pretty well and do a bit of tuning before you roll this out. But I'm happy to say at this point we actually have AuditD running on every single host in prod. So this is some of the most valuable data we have.
Got it. So, in talking about finding problems in the logs or finding anomalous behavior, what is the typical process for detecting anomalies and suspicious activity? Is there, like when I talk to banks or financial companies, there's this process of fraud detection where we probably do some kind of like vector similarity stuff with, or some machine learning driven thing for anomaly detection. Do you have anything constantly running like that's trying to learn what is typical behavior or identify erroneous behavior?
Yeah, so there are a couple of places, and I should give a shout out to ElastAlert, which is a Yelp project. So Yelp created ElastAlert as a way to monitor. It's not a security tool. It's like many of the tools we use, it's not specifically for security. It just happens to fill a need we have. And ElastAlert is something that allows you to do sort of a stored Elasticsearch query at an interval. And then you can do things like standard deviation, you can do spike, you can do drop off, and you can also just do interesting events. So a lot of the rules around what we're looking for AuditD wise, for instance, are actually ElastAlert queries that are just running constantly against the Elasticsearch cluster. And that's I don't know offhand how many rules we have, but it's quite a few. And when I talk about this, there's a talk where I've spoken at some length about the AuditD stuff we do. The rules that we use are, to me, the secret sauce, and really the only piece that, in my opinion, a company shouldn't share, right? Because it's the defender's advantage here. If you don't know what I'm looking for across all of my systems, then you don't know what you might trip over, right? And so we have a number of these rules that are just constantly watching all of this data. Obviously, those are not sort of adaptive rules, they're static rules, but on top of that, we have sort of an ongoing project that is just focused on looking at interesting indicators for things related to sort of employee activity, right? So what IPs somebody might come from, again, just as an employee of Slack, not for any of our customers. And then what you can do once you go down that path is actually build sort of a personalized IDS, right, per person. So historically, companies would look at something like IP logs and say, okay, we saw this request from Romania, and we don't, so that's potentially bad. But what if you have employees that work in Romania? I mean, what if you are a global company? You can't do that. So if you actually split that problem out to the individual and say, okay, I know this person is usually in this place, so if they deviate from that, then I want to know about it. You can do a bit more. You can do some more interesting things. And if you want to get really advanced on that, you could even perhaps. You could even keep track of, say, what commands they commonly use, or even what sort of actions they generally take on your systems. And this isn't, you might not necessarily block them right away, But as I mentioned in the blog post, you could use something like SecurityBot to verify their activity. So you still don't want to, you don't want to stop people from doing work, right? But you potentially, if you see somebody run a command they don't normally run, and you just send them a quick message saying, hey, was this you? And they say yes, no problem. And you can add that to the list of commands that they generally run. And I think that kind of thing is also very powerful. It's not machine learning, but I think it's powerful.
Yeah, so you mentioned something there, the defender's advantage, basically saying if you are the defender, your Slack in this case, you have the advantage of you've got a bunch of tripwires in place. The attacker does not know what those tripwires are. Are there any other examples of, because you talked about this in a YouTube talk that I saw, are there any other examples of where the defender's advantage applies to Slack?
Yeah, I mean, so, at the end of it, if somebody wants to compromise a company, they obviously have a target in mind, and doing a risk assessment on your company is extremely valuable here. Like thinking about, if I'm an attacker, what do I want? And in the context of risk for the company, what are we trying to stop people from accessing who should not have access to it? And so the advantage here is also knowing where your important data lives, right? So if you haven't sort of classified which hosts or which systems contain your most sensitive data, you really should. I mean, that's also extremely valuable. And the other thing that, a lot of attackers don't know. They don't know anything about your infrastructure when they break in. There's a thing I talk about. You mentioned you've seen the YouTube talk. I talk about the hypothetical malicious insider being the most difficult case, and it absolutely is. If somebody knows your infrastructure and has credentials to access it, that's really hard to defend against. But if an attacker comes in and they luck out and they just got credentials and they land on a Unix host, I mean, picture it with me. Like, what do you do first? And really, it's going to be discovery. You're going to be looking around, trying to figure out where the important stuff lives. This is, again, assuming you don't already know anything about the network. And so what happens is a lot of that is extremely noisy, but no one's looking for it. So when somebody logs into a box and they start going, okay, I'm going to look around the network and see what lives where, I mean, host file, DNS, they're going to start doing exploratory stuff. And that's surprisingly easy to spot in a lot of cases.
So something that's interesting about Slack, it kind of has changed the way that people do monitoring and the way that people do alerting. Slack has kind of become this hub for where a lot of companies are interacting with their business processes. Can you talk some about that? What are the and I'm sure at Slack, since you're doing it, the company itself is doing it. What are like the cutting edge ways that you're interfacing with your alerting system, your monitoring system? What are the ways that Slack itself, the product, has become integral to this monitoring and alerting and security process?
Yeah, so the alerting thing I alluded to earlier is a really key part of how we handle security here. So when we detect something strange, as you're aware, we send a message to the affected individual directly. And not in all cases, of course. There are certain cases where something is suspicious, and we send it straight to the security team. And we're very directly using Slack in that way. So it involves a bot called SecurityBot that handles. There's a component called Alert Center we wrote that is life cycle of alerts, right? So when something happens in any of our monitoring systems, it goes into Alert Center, and then SecurityBot is sort of constantly pulling Alert Center for new things to talk to people about. And when it sees something that it needs to notify on, it'll send that user a direct message and say, was this you, yes or no? And then that user can resolve the alert themselves. So the nice thing about this is it removes a lot of this from the security team's plate, and we go straight to the affected user. And the way that we verify it, because what you could do if you were an attacker and had access to someone's Slack account is, you could just say, yes, that was me, no problem, and then the bot would go away. or you could delete the message perhaps. And so what we actually do is SecurityBot then verifies via two-factor. So if you get an alert from the bot in a direct message, you say acknowledge, and then that actually triggers a duo push to your phone where you tap accept. And if you don't do that, then that out-of-band communication allows us to attest to whether the user typed accept or whether potentially an attacker did. And that's another really powerful thing, because what we do is we actually monitor more individually interesting events than we would if it was just a security team looking at this data. If we just had however many people we have, 12 people on the team, and we were all dedicated to looking at the little things that happen in our environment throughout the day, we would, first off, we couldn't watch nearly as much, but we would also probably tune out a lot of the stuff that really could be valuable information. And so what this allows us to do is sort of share the workload there among all of the employees in the company. And our goal is to not really annoy anyone, just to maybe a person gets 0 to 1 alerts a day, and that's great. But across a 600-person company, you're still watching a lot of things.
Yeah. Interesting. So what are the other ways that you feel Slack is changing the operations for different types of DevOps and security ops teams that you've met and interacted with? I mean, this is obviously a broad question, but I think there are a lot of companies that are doing some interesting things. So maybe you could talk about stuff that you've seen.
Yeah, there's a lot of stuff in the sort of chat ops realm. I think a friend of mine at GitHub has done some talks on chat ops, and I know they're very big on it. And I think the overall thing it changes is sort of people not working in a vacuum, and this idea of shared work, or at least many eyes on the problem whenever there's an incident. And what's great about it is when you integrate all of your tools into it, one of the things people like to say around here is Slack is sort of an operating system for business, and in that you connect it to a lot of the tools you use, and you sort of have this one place to go for all of the information you might need about something. Now, obviously that doesn't apply in all cases, but for things like alerting, for things like triage, for all of this stuff, you just have one place to go that is sort of universally known within your company. It's not go find a blog, or sorry, go find a wiki page from last year about how to handle an incident. You have all of this data right there, and it's searchable. And some of the really cool cases I've seen are, at least for chat ops, I know of one company that engages their denial of service protection by telling a bot to enable their denial of service protection within a chat, which I think is kind of a neat and novel case. The other thing I've seen is a lot of stuff around notification of incidents, so tying something like a PagerDuty in and just having that information pop right into Slack. And the reason that's also nice is just get in any chat platform, it doesn't have to be Slack, but having that data come into the place where you're actually spending most of your day conversing with the people you work with means that you're not sort of interrupting and checking other sources of information all the time, right? So you're not checking your email all the time, you're not checking all these other things. You probably have Slack open in a window off to the side, and that's also where you look for your alerting and some of your monitoring. And I think that's really useful and sort of streamlines a lot of these processes.
Yeah, the fewer services and social networks and things that I have to cycle through at the beginning of a computer session, the better. So, okay, just to close off, what are some points where the rapid growth and the scale of Slack have created some unique challenges around security?
So I think it goes back to what I said about inventory management. I think when you're a small company, it's pretty easy to wrap your head around how many endpoints there are. As you grow, we had to enlist people that had done this before at large companies and really understood how to manage a fleet and that kind of thing. Because as you grow, your surface area, your number of employees that could potentially be compromised grows as well. And I think the other thing is just general awareness of security issues. So I joined Slack when it was 50 people, and I want to say we're about 600 now. So that's a pretty massive growth in a short period of time. And there's a lot of sort of institutional knowledge that is hard to disseminate as you grow at that scale. So there are a lot of people that may just not, you don't realize it, but may not have the same have seen the same security discussions that everyone else saw in the past. And so keeping everyone up to date on what we should be doing and that kind of thing is also extremely difficult. And I think communicating some of that is really important.
Okay, well, Ryan, I want to thank you for coming on the show. This has been a great and wide-ranging conversation around security at Slack.
Yeah, thanks very much for having me on.
Thanks to Symphono for sponsoring Software Engineering Daily. Symphono is a custom engineering shop where senior engineers tackle big tech challenges while learning from each other. Check it out at symphono.com/sedaily. That's symphono.com/sedaily. Thanks again, Symphono.
Wow.